Example A. Write each equation in logarithmic form. To do a logarithmic form, you need a logarithm. So you must write down log. Then there's some other things that you need. I'm just going to put some different colors here on where things are supposed to go. We have the green spot, the blue spot, and the red spot. The green spot is the base. In my opinion, that's the easiest one. The base is the same as the base. Our base here is 4, so that means we're going to put in a 4 in for the base. The exponent, which was a 3, ends up going by itself in the equation for logarithm. So the exponent comes over here, 3. What was by itself, the 64, becomes the argument. So to change 4 to the third equals 64 to logarithmic form, it's log base 4 of 64 equals 3. So when you look at this, I mean, we're finished. We're done with that problem. When you look at this problem, there's nothing to figure out. It's just, this is stating a fact. There's no variables. We're trying to take baby steps into this because it's a different way to think. But when you look at what's in green and you get confused, what does that mean? It just means 4 to this exponent equals this number. 4 cubed equals 64, which is exactly what it says in problem number 1. It's a different way to write it. I have no idea who the insane person was that chose to put those numbers where they put them. Define big. 64 should be regular size. The 4 should be a subscript. The 3 is regular size. Would someone like to do number 2 for us? I won't watch, I promise. All right, I might take a peek. Concussion. Could you please start out with log, sir? So far, you're doing great. Using the correct words. Excellent. I'd like someone else to try number 3. Peanut M&Ms. Yeah. Peanut. Hit me.
Oh no, I got in trouble for throwing a joke. See? They're not heavy enough to throw.
You throw it like a small boy. I didn't want to say girl. Yes. The 49, is that small or big? You want to say base. Log base 49 of. Excellent. Questions? Example B. Write each equation in exponential form. We're doing this backwards now. Let me do this first one for you. Our base is 27. Easiest part, I think. Your exponent is what was by itself. It's a third. Equals what was your argument. Please try number 2. to share their answer for number 2? Concussion? Which is saying the same thing as the square root of 16 is 4, which we would all agree is true. Good. How about number 3? Snorlax? That's great. If you can remember how to change from one form to another, it's going to save you a lot of heartaches for a lot of problems, I would assume. Example C, evaluate each expression. There's lots of different ways to do these problems. I will show you a couple different ways to do some of these, and then when you can do some on your own, you can choose which method you would like. One method is to think, if we go back to our identities, looking at identity log ID number 1. It says if you possibly could write your logarithm as log of a base and your argument is the same base to an exponent, that whole thing just equals your exponent. If you can accomplish that in this problem, then it's real simple. So here's what I'm saying. Obviously our base is 2. Is there any way to write 32 that has a base of 2? 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. So if you can accomplish, once again, to get the base of your logarithm and the base of your argument to be the same, this is just going to equal whatever your exponent is. Our exponent's 5. Let's go back to the beginning of this problem. What does it mean to be a logarithm? This right here, I'm going to show you a different way to do this now. This means 2 to what exponent is 32? That's what this question is saying. 2 to what exponent is 32? So another way to do this is to take your expression and set it equal to a variable of your choice, such as x. Then change it to exponential form. This would be 2 to the x equals 32. (32) is the same thing as 2 to the fifth. So if 2 to the x equals 2 to the fifth, that means x has to equal 5. Two different methods to do the same problem, and I have no preference of what you do. Number 2, log base 10 of 1,000. If we could change this 1,000 so that it had the same base as the 10, which would be a base of 10. 10 times 10, that's 2 tens, is 100, times 10 more is 1,000. That means this is 10 to the third. Using log ID number 1, our base of our logarithm is 10, our argument's base is 10, this whole thing equals the exponent, which is 3. Using the alternate method, you would take log base 10 of 1,000, set it equal to a variable, write it in exponential form. 10 to what exponent is 1,000? Well, that's 10 to the third. You're asking yourself the same questions as you go. You're just presenting it in a different way to your mind, whichever is going to work best for you. Number 3 looks a little crazy here. Let's take the same concept. We want to change 1 divided by 343 to have a base of 7, which might be a little bit hard to concept. Is there any way to change that fraction so it wouldn't be a fraction? Concussion. Right. Take 343 and set it to -1. Now, please understand once again there are multiple ways to finish this problem. If you go back to page 2, well, it's page 2 for me. It's the second thing on your notes for you. And you look at the power property. Power property says if you have an exponent for your argument, you're allowed to move that out to the front. So if we do that, you don't. You don't. So I can do that -1 and put it in front. Now I have nothing negative. I have no fractions, which for some people, it might be a great thing. I have -1 times log base 7 of 343. So I want to stick with my original goal. I would like to write 343 that has a base of 7. Please enjoy my sharpener. I will charge you no money for that sharpener. Have a good day, sir. What is 7 to the first? Obviously 7. 7 squared? 49er. What's 49er times 3? 49. Did I say 49 times 3? 49 times 7 is what I meant. 7 times 9 is 63. Carry that little 6 over yonder. 7 times 4 is 28. Add the 6 to it. You get 343. Got to be real careful here. We have this logarithm right here. What you see in green there in parentheses, if you can see that green, that all reduces to 3. There's a negative out in front. So our answer is -3.